Woot! Calorimetry time parallelogram. Okay, time to talk about calorimetry.
Okay.
All right, this is really just an explanation of how to use Q equals MCAT twice to
Okay.
figure out one problem.
Well, the premise behind this is energy into one system is energy out of another system.
Right, so if I put something hot into something cold, I want to be able to measure exactly how much heat was transferred.
Energy in and energy out. Yep.
That way. Okay. Well, let's go ahead and look at what we got here. I've got a problem.
Let's do it.
I've got just one problem. Some people may disagree. Okay. So what we have to do here is first read the problem. So we have a piece of iron is heated to a temperature of 85 degrees Celsius. The iron is then placed in an insulated container with 100 mils of water. The temperature of the water changes from 23 to 27 degrees Celsius.
Okay.
So if we assume that there is no loss of heat, this is a perfect system. What is the mass of the iron? Whew, sounds like a lot. We also get a little bit of information here, the specific heat of both liquid water and iron. And we are expected to figure out the mass of the iron.
Okay.
Don't panic. Just write down the stuff that you know first. We are going to have to do Q equals MCAT
Twice.
for both.
Both systems, the iron and the water.
All right, so let's just set this up. I'm going to put my iron over here.
So what's happened while you're writing all that out, what's
Sure.
happened is we've heated up a piece of iron and dropped it into water. So the temperature of the water has gone up until they both reach the same temperature, and then the heat transfer stops. Makes sense. Heat something up and drop it in.
It makes perfect sense to me. Does it make sense to you guys? Oh, you can't answer us. Oh boy.
Okay, so
what do we have? I'm going to go ahead and write my specific heats because I already have them, right?
okay,
I have, oops, not that. I have 4.18 joules per gram degree Celsius is the specific heat for water, and 0.450 is that for iron. What else do we have?
we know how much the water temperature changed. So we went
Okay.
from 23 to 27. So 27 minus 23 is 4 degrees Celsius.
Okay, the temperature change is a positive 4 degrees Celsius.
The mass of the water.
The mass of the water. Okay, so yeah, 1 milliliter of water weighs 1 gram.
Right, because you can use density if you needed to, but it will almost always be water.
Okay, so 100 grams of water. I'm looking right here, and like I already can figure out what the Q of water is.
Right, and that's how
So-
much energy went in to the
Okay.
water. So
Okay.
the Q equals MCAT would be 100.
So we multiply everything together, and that would be what 1,672
672 joules.
joules. We definitely didn't do this beforehand. We're doing this all in our head right now. Okay, so we multiplied all of these together to get this right here. So what we have to understand is that was the Q into the water,
Right,
right?
energy in.
And real quick, I kind of want to just show you guys the Q in is going to be equal to the negative Q out. Remember the heat came out of the iron and went into the water. So if that's the case, then this guy right here, we can put it all the way over here to the Q, right?
But it's negative.
But it's negative
It just shows direction.
1672. So 1672 joules out of the iron, negative, into
The water.
the water. Let me erase this little thing so nobody gets confused. Okay. Okay. So now we got to figure out the mass of the iron, but we still have to figure out the delta T
Okay.
of the iron. So
So-
what do we have to do here?
So the initial temperature was 85.
Okay.
The final temperature is 27 because the
How did-
heat transfer stopped when the water reached 27 degrees. So they both would have the same final temperature.
That's really important to remember. Both have the same final temperature. So we do final temperature, which is this guy, minus initial temperature, which is this guy, and that gives us negative 58. If we don't have a negative temperature right there, a negative temperature change with our negative Q, that's going to give us a negative mass.
Right, and that's
You
it.
can't have that. So if you get a negative mass, relook at what you did. All right, so what we have to do is then we have to do our Q equals MCAT again, and I'm just going to write this one out. So negative 1672 equals mass times 0.45 times negative 58. And we're going to do some algebra. Divide both sides by this. And what do we end up getting?
For mass, 64.1 grams. That's a pretty big sample of iron.
So this, I wrote it in blue because this is what we were originally asked for. You see how we went through all of that information and we found exactly what they were looking for, and using an equation that is hopefully familiar or will become familiar to you guys. So that's pretty much it.
Yep. Good luck.